Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell, then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you'll see the links for the O-level and the A-level group. Welcome back, students. This is coordination session 21. We are continuing with the advanced biology coordination, and in the previous session we discussed all the facts about the properties or features of the action potential. So in this session we are going to continue with the transmission of the nerve impulse along the axon, or propagation of an action potential. As we said in the previous session, that one among the properties of action potential is propagation. And if you remember, I told you that action potential actually does not propagate in the nerve impulse, but the process of formation or the process of moving the action potential from one point of the nerve impulse of the nerve cell to the another, it is actually the process of forming the new action potential at each site. So action potential at one point causes depolarization of the near point, and then it causes the near point to produce the action potential. So we are saying that although we often speaking of axons as conducting action potential or impulses, action potential do not really travel along an axon, but they are events that are produced at different points along the axon membrane. Events that are produced at different points along the axon membrane. This can occur for two reasons. The first reason, action potential are stimulated by depolarization, and the second reason, an action potential can serve as depolarization stimulus. So action potential yenyewe inatengenezwa inakuwa stimulated by depolarization. Yani action potential itengenezwe lazima kuwepo kuna depolarization, lakini pia action potential yenyewe kitengenezwa yenyewe ina act kama depolarization stimulus, maana yake ina stimulate nerve ifanye depolarization nyingine. So the movement of an action potential through the axon is not generated by ions flowing from the base of the axon to the end. So ions has a flow kutoka kwenye one point of the axon to the another. Instead, an action potential originates at the base of the axon, and is recreated. It is recreated means at every point you are creating another action potential. So it is created at the base, then it is recreated along the axon. So each action potential during its rising phase reflects a reversal in the membrane polarity. The rising phase of action potential, that means the membrane undergoes depolarization. That means the inside becomes positive, outside becomes negative. And the positive charges due to influx of sodium can depolarize the adjacent region of the membrane to threshold. Kwa positive charge inayokuwa kwenye action potential moja kutokana na kuingia kwa sodium, hiyo inasababisha depolarization ya next portion of the axon. Hence na yenyewe inatengeneza ni action potential, so that the next region produces its own action potential. Kwa hiyo ile ya mwanzo ndio iliyokuwa imetengenezwa kule mbele, imetengenezwa nyingine. So meanwhile the previous region of the membrane repolarizes back to the resting potential. Baada ya muda mfupi narudi kwa resting potential. The signal does not back up because the sodium channel that have just fired are still in the inactivated state, and they are refractory resistance to the stimulus. Kwa hiyo signal yenyewe au impulse haiwezi karudi nyuma, haiwezi kurudi nyuma. Kwa sababu gani? Ikipita sehemu zile sodium channels zikiwa bado ziko kwenye refractory period, signal imeshapita, imeenda mbele. Now below we have the diagram. And here there are explanations of the diagram. The diagram has 4 parts. The first part is the resting potential. Voltage gated ion channel are closed, but there is some of the diffusion of potassium. In response to the stimulus, the cell begin to depolarize. So actually this diagram explains the cycle of what happens in the neuron. During conduction of the nerve impulse. So as you can see, the explanations for the diagram they are above, but here you can see, you can observe yourself what happens. This is the resting nerve cell. And here in the resting nerve cell, we have the potassium channels. They are opened, and they allow the potassium ions to be exchanged. Then you have the voltage gated sodium channel. Also we have the voltage gated potassium channel. So these are voltage gated sodium channel, voltage gated potassium channel. At resting potential, only the potassium channels they are open, but the voltage gated sodium and the voltage gated potassium they are closed. Now this number 1 is the position here at negative 70 millivolt. So now let's see when the action potential start to develop at number 2, means the voltage gated sodium channel will be opened and will allow the sodium ions to enter. So this is number 2, the voltage gated sodium channel, they have been opened due to depolarization, and the sodium ions they enter. So that is the rising phase of the graph. Then from there we have the top of the curve. Here at the top of the curve, maximum voltage is reached. Here the sodium gets the close and the potassium gets the open. This diagram shows what happens. The sodium gets the close and the potassium they do what, they open. So after opening, the potassium gets allow the potassium ions to enter and the graph falls. So what happens actually is that after the entrance of potassium, and the graph falls to hyper-repolarization, the falling phase, and a shoot occurs as excess potassium diffuses out because potassium channel closes. So after there, the sodium channel will close, and then the potassium channel will allow the potassium to move out. Also, there is mechanism of the action potential which tend to restore the resting potential in these conditions. So actually this is the cycle of event which takes place during the conduction of nerve impulse. So at every point of the cell or at every point of the neuron, what happens in the cycle like this. And we have already discussed this in the topic of action potential, how the action potential is produced and how the nerve cell comes back to the original resting potential. But I have reviewed this session to do a recap, so as when I am going to discuss about the mechanism of transmission of the nerve impulse, it will be easier for you to understand what I am discussing about. So let me end up here in this session, and in the next session we'll be discussing about the mechanism of transmission of nerve impulse, what actually takes place at each point of the nerve impulse until the nerve impulse propagates from one point to another. So thank you everybody, and don't forget to subscribe the channel and to share the video link to your fellow students so that they access these lectures. Thank you.